beta is equal to F3 divided by sine gamma. So this is also one more theorem. That is, this is called Lami's theorem. Lami's theorem explains or talks about three forces when acts on a body, and the body is in equilibrium, body is not getting accelerated. Then in that condition, we can write F1 sine alpha is equal to F2 sine beta is equal to F3 sine gamma. How these angles are managed, that also I think you followed it. This is what you call Lami's theorem, equilibrium of concurrent forces, all this, right? So Lami's theorem, also using Lami's theorem, there are several the numerical problems are explained in your textbook. You will see the textbook and find questions related to Lami's theorem and also equilibrium of concurrent forces, etc. Next, we are coming to Newton's laws of motion. Newton's laws of motion, Newton put forward two, Newton's first law, Newton's second law, and Newton's third law. According to Newton's first law, Newton's law of motion, first law, Newton's laws of motion, first law, Newton's first law. Newton's first law of motion. According to first law of motion, every body continues in its state of rest or uniform motion in a straight line unless and until it is acted upon by an external force. This is called Newton's first law of motion. Newton's first law of motion is important because Newton's first law of motion gives us an idea about force, a qualitative idea about force, qualitatively, not quantitative. Right? A question can be asked, what is the importance of Newton's first law of motion? According to Newton's first law of motion, every body continues in its state of rest or uniform motion in a straight line unless and until it is acted upon by an external force. Quality of a force is described in this law. That is why this is important, because it gives us a qualitative idea about the force. Understand? So Newton's law of motion, first law, has two parts. One is Newton's law of motion, that means inertia. It is actually talking about inertia. That means inertia of motion and inertia of rest. Both are explained in this law. Right? A body which is at rest continues to be at rest till when a force is acting on it. A body which is in motion, that will continue to be moving in a straight line until a force is acting on the body, or force comes as an external agency. Till then, the body will continue to be in these two conditions, either at the rest or in motion. This is what is called Newton's first law of motion, right? So Newton's first law of motion importance you understand, because it gives us a qualitative idea about force. Now next, I am going to tell you about another quantity that is called momentum. What is momentum? In this class, I will talk about linear momentum. L-I-N-E-R. Linear momentum. What is linear momentum? If anybody is, this question is asked to anybody, they will say that, sir, the product of mass and the velocity is called momentum, right? I will change it a little bit. Change a little bit. What is linear momentum? Linear momentum is the quantity of motion possessed by a body. Right? Quantity of motion possessed by a body is called linear momentum. It is measured as the product of mass and velocity of the body. Right? It is denoted by a letter P. It is actually a vector quantity. Therefore, vector P is equal to mass into velocity. Mass is a scalar quantity. Therefore, mass into vector V we can write. Am I correct? So it's a vector quantity and it's a unit. What is the unit of mass? That is kg. What is the unit of velocity? That is equal to meter per second. Therefore, its unit is what? Kg meter per second. Or kg meter s raised to -1. And its dimensions are what? M, L, t raised to -1. M, L, t raised to -1. This is the unit of this physical quantity. Now we can say that suppose two bodies having different masses. One is a capital M and other is small m. Suppose both are having the same momentum. One body has a mass is capital M, other body has a mass is small m. They are moving with the same velocity. They are moving the same velocity. It's not same momentum, but I am sorry, right? They are moving the same velocities. Then first body has a momentum P1 is equal to m into capital V, and the second body has m into small v. Okay, m into small v. Second body has a momentum P2 is equal to that also m into a small v. Both are moving with the same velocities, same velocities. Then then what we can say, same velocities, then P1 is equal to m into small v and P2 is equal to m into small v, small m into small v. But remember, capital M is greater than a small m. Then P1 by P2 is equal to what? P1 by P2 is equal to capital M V divided by small m V. V and V cancel because they are moving the same velocities. Right? Therefore, what we say is that that means the P1 is greater, M is greater than. Here you will say M is greater than small, capital M is greater than small m. Therefore, P1 is greater than P2. So when two bodies of different masses are moving with the same velocities, then the momentum of the body having greater mass will have that greater mass will be more. That means when two bodies are moving the same velocities, then the moment of which body will be more? The momentum of the body having more mass will be greater. That is one thing. Next, we can say that two bodies of different masses. So you follow this condition, right? This condition followed. Next is two bodies are having right? So what is the moment of the first body? That is equal to m capital V. What is the moment of the second body? That is m small v. But I say that these two momenta are equal. Then I can say that m capital V is equal to m small v. I can write m small v. I can write. Okay. Therefore, we can write capital M divided by small m is equal to small v by capital V. Small v by capital V. That means m is inversely proportional to v. That means when two bodies of different masses are moving with the different velocities, then different velocities, right? But having different mass, different velocities, but their momenta are same. Then what will the lighter mass will have more velocity? That means m is, that means you see, you can write generally m is inversely proportional to v. That means greater velocity, less mass. That means velocity is inversely proportional to v. So two bodies can have same what you call momentum. They are moving with different velocities. In that condition, you must understand that the smaller mass will have more velocity and the greater mass will have less velocity because their momenta are same, but velocity may be different. So two bodies can have two bodies of different masses can have same momentum, but the velocity of the body will be different. Which body will have more velocity? The body having less mass will have more velocity and vice versa. So this is another. So this best example you can say the bullet is fired from a gun. Soldiers when operate a gun, they keep it in the right side and operate it. When the bullet goes out, the gun will be moving backward. This is called a recoil of the gun. So when a gun is fired, uh, two momenta will be arising. One is the momentum of the bullet and other is momentum of the gun. Right? Bullet, the mass is very less, while the mass of the gun is very bigger. Understand? The bullet goes with a very high speed. Why? Because the mass of the bullet is very, very less. Okay? But the momentum of both are same. That means small m into small v is equal to capital M into capital V. Both the momenta are same. There is no change in the momentum. This is what's called conservation of momentum. So in a system, the momentum of all particle system will remain same. So gun and bullet, this is single body only. Due to some variation, something happening inside of the gun, the bullet goes out. That time, the gun is moving in the backward direction. That is called a recoil of the gun. So momentum of the bullet and momentum of the gun both are same, but because the bullet is of a very small mass, it goes with a very high velocity in the forward direction. That time, the gun of large mass will move with a small velocity in the backward direction. This is the best example of this, right? So linear momentum is also over. So linear moment. Next is second law of motion. Newton's second law of motion also I will explain. That is very important. Because according to Newton's second law of motion, the rate of change of linear momentum is equal to force acting on the body. And it acts in the direction of the force. That means rate of change of momentum is acting in the direction of the force. This is what we call second law of motion. Newton's second law of motion is basic law of motion because Newton's second law of motion can be used to derive or to explain Newton's first law of motion and also Newton's third law of motion. That is why we say that Newton's second law of motion is very, very important. Bit more important than first law, right? First law because it gives us the first thing, it gives us a quantitative idea about force. We will be getting an expression for force, a quantitative idea about force. That one gave only qualitative idea. Here we will get quantitative because this law only gives us an equation for force, physically. And also the other thing is that this is the basic law of motion. Why that? Because Newton's second law of motion can explain or that can derive the first law of motion, the first law and the third law can be derived using second law of motion. This is a very important thing. So according to Newton's second law of motion, what I said, the rate of change of linear momentum is equal to is directly proportional to the force acting on the body. Right? Suppose that a body is moving at the velocity v1. That is having a mass m and it is moving